This is the video on Chapter 7, Section 6. This is solving radical equations for MAT 1033. Here's the first example problem. You can see that we have square root of 2x minus 3 equals 9. First of all, you need to understand that in order to solve these radical problems, there must be a radical on one side by itself. Because then what we do is we square both sides. Remember, in algebra, what you do to one side, you have to do to the other. By squaring the square root, we end up with 2x minus 3. Squaring 9, we get 81. Now it becomes a two-step algebra problem. Add the 3, get 2x equals 84. Divide by 2, you get x equals 42. That's really all there is to these problems. You just got to make sure that you get the radical on one side by itself. In this example problem here, we don't have the radical on one side by itself. So the first thing we do is we subtract the 3x over. Now we can square both sides. And when we square, we get the negative 10x minus 1. Do not forget this is negative 3x times negative 3x, which gives us 9x squared. Now, what I did here was I added the 10x over, added the 1 over, and then switched sides. Remember, you always, in a trinomial, you always want your x squared term to be positive. That means anything else you want to move to it if it's already positive. When we get to 9x squared plus 10x plus 1, we have a trinomial that can factor into 9x plus 1 equals 9x plus 1 times x plus 1. We set each factor equal to 0 and solve. Subtract the 1 over, divide by 9, we get x equals negative 1/9. Subtract the 1 over, we get x equals negative 1. And we're where we need to be. And if you look at what's happening here, okay, I always have to check these because remember I can't have a negative inside the radical. So if I take that negative 1/9 and place it back up here, negative times negative gives me 10/9. 10/9 is larger than negative 1, so it becomes a positive. If I take this negative 1 and put it back up here in the equation, negative 1 times negative 10 is a positive 10. 10 minus 1 is 9, so it works as well.